Cool. Okay, today I'm going to be talking about Docker, and then especially the way it changes the way that it is changing it for you to develop and release scalable solutions. It's kind of a vague term to use, scalable solutions. I played with it. Which one should I use? I tried to use microservices, but that was just narrowing the scope, which is not, it's not only about microservices. I tried to use distributed services. That, sounded scary. So I use scalable solutions. Hope you will, pick up some stuff, even if it is not relevant in terms of scalability to you. I will try to show some interesting stuff about Docker today. Cool. So a little bit about me. My name is Tugberk. I have a Twitter account, blog, and I'm active on Stack Overflow and GitHub. So you can follow me in those places to see what I'm up to. I live in UK, work at a company called Redgate. I'm a software developer there. I live in Cambridge. It's a green place, nice to live. So today, as I told you, I'm going to be talking about Docker. But what's the problem that Docker exists to solve, and what are we struggling with, right? There are actually several of them. But first of all, the biggest one, I think, that to me, is that when you are basically writing a software and building a software, you can't just use one thing, right? You can't just use one, for example, hammer to do your thing in real world, right? If you are going to be building a nice piece of furniture, for example, you can't just build it with one tool. So in our case, in terms of software development, it is the same thing. So we can't just use one thing, right? For example, .NET framework, right? Or Java or Ruby. We can't just pick one of them and then say that, okay, I'm going to be building my application from scratch with this thing only. I'm not going to use anything else. That's just not realistic. Maybe it's realistic for some of the applications. Like if you are building a calculator, that will be nice. But most of the time, it is the case that we are building applications which has some context, some working with some type of data. So in these type of situations, we want to use the right tool for the right job. You may think that, okay, yeah, I use SQL Server, I use .NET. Those are the two things that I'm using, and that's okay for me. That's completely understandable, completely okay. But the way that we receive data in a modern application is not just the way that we have been receiving before. So today, if you are building an application, it's most of the time the case that you are playing with a large amount of data. And I'm going to be giving you an example that from a project that I work on during the nights with my friend, and then you will see what I mean by that. But if we have lots of tools to work with to work on a software, we just end up with a picture like this, right? It's hard to find which one is where. It's hard to plug them in. And if you go, sleep and then wake up tomorrow, try to find a place, try to find a tool where you have left is hard as well. So, but I mean, it's not hard actually, right? We have solved this problem in real world, something like this, right? It's very tidy now. You put stuff into right places. You don't, leave them in a mess. And whenever you want to go to sleep, you just close the thing, and after that, you open it again, and then you find the stuff there, which is very nice. So Docker is actually, designed to solve this problem as well. So it solves lots of problems, but it's one of them is this one. The other one is that we have inconsistent environments, right? So, for example, when we are developing our application, we develop it in our machines, and then when we put it on a testing environment, we, bring up the testing environment. But that testing environment is not like our development environment most of the time. It's very different. And QA environment, for example, that's another one, which can also be different. Even if you strive for the complete, consistency between them, you will struggle to find, you will struggle to do that in most of the cases. And production is one of them as well, and which you most of the time get the problems and try to reproduce them, which doesn't, go quite well. So the result is that so most of the time the project, it's hard to onboard, right? You go to a project, you start on a new job or something like that, and you look at the README file and you see a large README file which says do this, do that, do that, do that, and then at the end of the day you will be running your application, which is most of the time the case. But we will see how we can actually reduce that onboarding experience. Different environments, inconsistency between them, right? So we will see how to reduce that as well. And also, there's a saying that use right tool for the right job, right? You can't just go and use a hammer to, I don't know, do something which doesn't make sense, and then you go and use some other tool for something else. So you can use right tool for the right job. For example, if you are writing a worker application which just receives data, processes it, and then gives it back. It's like you have an immutable structure in your hand. You just do some processing and then give a result back. Functional programming languages is awesome for that. If you are working in a mutable, in a mutable state, object-oriented programming languages are very good for that. If you want to just be, like, I just want to get this done, Python or JavaScript is very good for that. You may argue that JavaScript is not good for anything, but it might be good for that. And there are these type of situations are gonna, you see that you want to use different tool for the different thing, but when you actually combine them together, you will see that you need to have different deployment needs for each of them. So you don't have a basically abstracted way of deploying everything to a server. You will need to say, okay, I want to install this into this server, I need to install that onto that server. So it's just going to be very weak at the end of the day. And this is one of the problems. And then the last one that I want to mention is that the hard to reproduce production issues. When an issue comes in a production environment, you want to reproduce that. And to be able to do that, you need to basically replicate the production environment, because some of the issues are coming from the application and some of the issues can come from the infrastructure basically. So to do that, you basically need to reproduce the exact environment. But I've been talking about the problems, but what is actually Docker is? How many of you guys are using Docker today? Okay, cool. How many of you guys have heard of it? How many of you guys know what it is? Roughly the people who are using it. Cool, okay. So what Docker is actually a really clever thing. I should basically accept here that I am not a hardcore Linux person or anything. I have been a Windows person for like 5 years or so. I'm still using Windows. This is still PowerPoint. But I have been getting into the Linux world for a year or so now, and using it actively for 5 months now, and I quite like it actually. And I'm learning about the concepts which are very different to Windows now. For example, I discovered the Unix sockets a few days ago, which just blew my mind. Everything is filed in Linux. And the way that this Docker thing works is it's a container technology, and it sits on top of something called user mode, as far as I know. And it is basically a virtualization technology on top of that, and which doesn't actually give you the overhead of a virtual machine or anything. So it basically gives you an engine that you can put all of the dependencies on top of it. Being shared is the kernel. So whenever you issue a kernel call, Docker engine basically gives it to the underlying operating system's kernel and then issues the call from there. I'm basically overly simplifying it, but this is how I understand it, and that makes it easy for me to grab what it does at the end of the day. And it also provides you a good isolation, so you can basically package up all of your dependencies into one giant zip file. Basically, think of it as a one giant zip file which includes everything in it. Your runtime, framework runtime, for example, if you're using Ruby, Ruby is in it, and it runs on Ubuntu, for example, Ubuntu is in it, and maybe you are using some other stuff inside it, and then you basically also include them there. But the general concept in Docker world is that do one thing and do it well. So you wouldn't actually say that, okay, I'm going to be building an application which has, MongoDB, Ruby, and some Golang, and two processes running at the same time, blah, blah. You wouldn't package them up in one container. You would package them up in different containers, and we will see how it is being done later. And that's actually going to allow you to basically separately, maintain each of them. So that's another good thing about Docker is that it provides you a good isolation there. And the environments are consistent because you can work with Docker on development environment, on your other environments, including production. So what happens is that when you are working in a development environment, you basically have the same stuff that is going to be running on the server, including your web servers, including your load balancer even. So you can basically run everything inside your development environment, and you can switch some stuff. For example, if you are compiling a .NET application, you can compile it in debug mode on your development environment, but when you go to the production, you can say the switch. You can put a switch there, say that, okay, compile this on release mode. And then you can even map some files from host to the Docker container to do some nice stuff like debugging and so on and so forth. So these are basically the stuff that Docker gonna give you. And then because of that, the environments are gonna be very consistent. Docker is not only one tool. It doesn't. The Docker engine is the basic core fundamental of everything, and then there are several tools built on top of that, and then some of them are just sitting next to each other. So, for example, Docker Compose is one of them. It is basically you can think of it as a combining every containers, and then you can basically say inside a manifest file. This is my application that I want to run, and then you can say Docker Compose up, and then it will get all of the application running, including all of the containers that you specify, and then you can even scale them individually or scale all of it if you want to. So it's a nice utility tool that you use on top of it, which is only suggested to be used in development environment, not in production or not in other environments. Which makes sense. And there's also something called Docker machine, which allows you to create Docker machines all over the place with abstracting the underlying infrastructure. Like, for example, if you want to create a Docker, if you want to create a Linux machine on Azure, you use Docker machine to do that if you want to, and it will get up a machine there, but you will not know how it is being done. It will use the underlying infrastructure of Azure to do that, or in AWS, or in your, for example, VMware or VirtualBox. So it will use that. And then there's also something called Docker Swarm, which gives you a nice way of doing a service discoverability. And the last one is Docker Registry, which basically holds all of your images. So Docker containers are combined images that you pull from several sources. And it has a very clever way of determining which layers you are using, and then so that it can do some very advanced caching in your environment. So if you pull Ubuntu in one container, you wouldn't pull it in another one if you are still pulling the same version. So it would say that, okay, you already have this layer, I'm not going to download this. So I will just give it to you. So it has a very nice environment, very nice feature there. And the Docker registry holds all of your images. It's like a NuGet feed, or I think in npm in JavaScript it's npm. So you can think of it that way. So this is basically the Docker family that you will probably hear the most. There are a few other stuff, but these are the basics that you will see. So let's do a demo. A very, very, very easy one actually now. Get what information. So this is the code that I'm going to be running. So I have a Linux box here. So I have Docker there. So you see that there are Docker is a command line. So this is the client that I'm using now, and there's also a host running in this machine as a service. So what I'm going to be doing is I will just run this command, and this is going to be doing something very silly. So what it does is it tells that Docker run this image, which is called Ubuntu, and then run this command inside it, and then exit immediately when the command is exited. So it will just say echo hello world inside Ubuntu system, and then exit from there. And it will just do that and exit it. You don't basically realize what's happening here, maybe. You are seeing, okay, you are just writing hello world here. But this hello world is being written inside another operating system, basically. And it gives me the output from there. This is a very basic example, and it pulls the Ubuntu image from the Docker registry, and it pulls it there. Because I have pulled it before, it didn't download it now, it just used the underlying one there. So for example, if I do Docker PSA, I should see several containers here, and you can see one of them is Ubuntu here, and then there is also a command that I have just run. And you can see when it has been created, when it has been exited, so on and so forth. So this is a very basic example of how you use Docker. But this is, as I said, this is very, very fairly simple one. But it can give you an idea that you can even, package up your developer tools. Like for example, if you want to just play with Go language, you wouldn't actually need to install the thing in your machine. You can just pull the Golang Docker image from the registry, and you can say that, okay, I want to basically open a terminal session inside the Golang container, and then from there you can just play with the Golang inside the container, and when you are done you can just exit it, and everything will be just inside the container, and you can even delete the container after you are done. So this is very powerful in that manner, but it's mostly powerful in ways that you package up your applications. So there's a sample here which I linked here, so you can actually look at it there. But this is basically the Docker file. So you basically compose your applications, you compose your Docker images inside the file, and this is the manifest that you write. And it's very declarative, as you can see. You say that, okay, I want to base this an image, which is the very top one, top command, top declaration here, which says this is the base image I want to base this on. And from there, you are just doing your thing and saying that copy this file, run this thing, copy this thing. And it is very nice that it can do the caching as well. So for example, what I'm doing is I'm copying the project.json file here, which is, you don't need to know what it is, but what it does is it basically holds all of the packages that I have for that application, and I'm just copying some config file, and I'm running a package restore. So what it does here is that it caches this layer and says that, okay, whenever the file project.json changes, I need to rerun this. Otherwise, I don't need to do that again, because that file is there, and it's going to be the same thing. Right? So, and then I add all of my files there, and then basically declare what is going to be my endpoint, what's going to be my working directory. So, unless I change the project.json file, I'm not going to be restoring the packages again. It will just, copy the files and put it there, which is very fast comparing to doing the package restore. So it's very, it has very nice, little things there, here and there. As I said before, you can package the developer tools. In this case, it is packaging up the AWS CLI so that you can use it in a Docker container. It gives you a nice way of, doing stuff. You can use your own build your own like this. Or there are several stuff inside the registry that you can use those as well. As I mentioned before, Docker registry is the stuff that you put your images, public images. You can purchase a private code and put it on a server and then run it yourself, and then store the images and maintain it yourself. So it's very open in that case. Docker Compose. I'm just going through this very fast, so I want to get to the actual demo. So what Docker Compose does is, again, it combines all of your application infrastructure, right? So this is the file that you declare what's going to happen. This is all of it. So in this case, what I'm doing is I'm running, and I want to run an application, but that application relies on RabbitMQ. So what I would do usually is that I would go and install RabbitMQ, put it on my machine, right? And I would go and wire this up with my developer environment, say that, okay, this is the actual URL of the actual endpoint of the RabbitMQ that you should use. And all of that stuff that is going to be basically hard-coded inside my thing, or I would use environment variables, but I need to still, I need to basically set them every time I want to run it. But here, I'm declaring what's going to happen here. I'm saying that, look, this is the RabbitMQ Docker file that I have, and this is the ports that you need to open for me. And again, the second one is the Rabbit sample, and this is the Docker file that you need to build. And this is the Rabbit, this is the container name, which is Rabbit sample. And these are the environments variable that you need to have. And there is also one more thing at the bottom, which is very important, the link between two containers. So you can link two containers between them. And what's going to happen at that point is that you can talk to the other container from that container. So what I want to do in this case is that from the application, I want to talk to the RabbitMQ, but not the other way around. So my application will be able to talk to RabbitMQ because I'm declaring a link between them. And it will basically give me a DNS registry as well inside the host file, so that I can use that as an endpoint on the one of the environment variables. You can see that last environment variable, I'm using that container name as my endpoint name. So let's look at this, how it's actually being done, and when we run it, what's going to happen. So I'm here inside the sample. You can basically reach out to it on my GitHub repository. So what I'm going to be doing is I'm going to be running Docker Compose build, which will just output some stuff for me. It will not do anything because it's already being built before, and it's just saying, okay, you have all of the stuff ready for now. And what I'm going to be doing now is I will run Docker Compose up, and it will go and run the containers inside it, which are two containers, right? So it is starting up the RabbitMQ now. RabbitMQ is there. It's getting up. And then now my sample is started actually. What my sample does is it publishes a message from one thread and receives that message from other thread. It's very simple in that manner. And you can see what it does here actually. This is also available on GitHub if you want to see that. But you can see here, I just clone the thing and then run Docker Compose build and Docker Compose up, and it's already there. I don't need to install anything else. This is just the thing. So this is a very basic sample of how you can get a very. This is also very nice for prototyping if you want to prototype this type of stuff. So I think those should give you some idea about what it can do. And these are the very basics, actually. But I'm going to give you a complete example now on something that I use. We built with my friend overnight. And it's something called Sleepcalm, which just has a web page now, which you can subscribe to the mailing list and we can spam you. We are basically building it, but there is nothing that we want to, basically, we are not confident to put it out there yet. So it's going to be basically your recommendation engine on eating, so you can basically put your profile there and it will tell you what to eat. The actual stuff here is that it uses so many technologies. And it uses so many technologies not because of, we can. It uses each of the technologies that make sense to it. We started this application with a SQL server and a .NET, application. We saw that it's not going to work out at all with that amount of data. So we just had to make some decisions along the way, and I'm going to show you how the structure is. But at the very basics, it is embracing polyglot persistence. Not technology, but paradigm, I can say maybe. How many of you guys are aware of polyglot persistence? Cool, not much. Okay. So, to give you an idea, this is the traditional look, right? How many of you guys have this type of application out there? Right? It is, you have one application, one database, it is looking at that, and then pulling data from there. But it's doing everything there. It's doing the search there, it's getting the product details there, for example, in terms of a online e-commerce website. It's doing the shopping cart stuff there, recommendations, it's getting it from the same place, and it gets the reports from the same place. Which can work out, in some cases, but if you have like lots of data, you will struggle to index stuff. It will get into your way because it's a very generic thing. It's not built for some specific scenarios, right? So how you would approach this in a polyglot persistence manner is that you would use the right tool for the right job again. So MongoDB, for example, it's very good document store. You can put some stuff there. You can get them by ID. If you have a large amount of data, it scales horizontally amazingly well, easy. You can do replication so easy. You can do sharding so easy. So you can just put stuff there, do some listing, and then get some stuff from by doing a primary key lookup. It's very good for that. So you can do product detail. You can get the product details there. You can even put your shopping cart there. It's very easy in that manner. Elasticsearch, for example, amazing search engine that you can use, and it does the search very well. So you can use the Elasticsearch for searching, right? And Neo4j is an amazing graph database that you can use to answer some amazingly complicated questions. For example, it's very good for recommendations, so you can use Neo4j for recommendation. And SQL Server is very good for reporting, right? We all know that we're all in love with SQL Server because of the reporting feature, basically. So what you see here is that you have basically 4 data technologies that you are using for one application, maybe. This is cool. I mean, looks great, right? But it is, you can think of how am I going to build this, right? So in our case, in the Sleepcalm case, this is our very simplified diagram right now. What's happening here is that we have a load balancer. Load balancer goes and looks at the actual APIs, and APIs are being split into multiple servers. It basically gets it from there, and from that it goes to and talks to the right database. Sometimes it sends a message to the queuing system, and then gives back the response. There's even caching is built somewhere here. I didn't actually put it there to simplify it, but this is a very simplified structure of the whole system. And then on the right hand side you see gray boxes, and those are the workers, processes that are running to do some other stuff. So you may say that, okay, you use multiple data storage technologies, but how are you going to make sure that data exists everywhere? So first of all, if you are going to be building this type of application, you need to embrace eventual consistency first. And then later, you have so much to do in terms of where to put actual right data into the place. So those workers exist because of that. Those workers are basically looking at stuff, putting it in places. so that you would get the right data from the right places. And it does some asynchronous processing behind the scenes as well, like recipe generation is being done inside the worker process because it's a lengthy process. And because if you want to do it very fast, you can get up and running hundreds of servers to do one recipe generation, for example. So it's very scalable, it's very nice, it looks great, but in terms of development, it is not going to be very good, right? So first we had this architecture, it was very good, it's working nicely in our log tests, in our actual tests, but when you land on the GitHub project, you see a README file like this. This is not all of it, this is just the beginning, right? It says what type of requirements you have to run this project. Great. Getting started with the project. Okay, we are getting started now, right? If there are some links there, and then there's a build.cmd file, all great. Okay, it's now getting complicated. It says that you need to install MongoDB, put it somewhere, right? You may argue that you can do it with a script, but I mean, you're going to be running the script at the time. You will still put it on your machine. And imagine that you already have MongoDB running somewhere in your machine, right? So this is the MongoDB setup. Not all. You also need to set up Elasticsearch to run this. And at that time, we didn't have RabbitMQ and Neo4j. So these are just the two things that I'm highlighting. And you would have RabbitMQ and Neo4j here, in our case. So it's not scalable if you are going to be onboarding, right? But what's going to happen now is that we have inside the project structure, we have this type of Docker files that you are it's going to be using, and setting up the project is just this 3 lines. It says that clone the thing, run compose build, run compose up, and the application will be all up and running for you, and you can hit the endpoint. This is all there is to do, and to give you the demo, I'm going to be showing you the actual bit here. So I'm here now under the Sleep project. So this is all you can see inside the root directory. I will do Docker compose out, and at this point, it will run all of my containers. One other thing that we are doing here is that we are also provisioning the MongoDB database. So what we do is we basically say that, okay, there is a backup file that we have somewhere for MongoDB to get a development, development environment up and running, so that you can use some set of data to work with on your development environment. And it pulls that data and restores the backup on MongoDB, so that you can start working with the application. So it's all running now, including the workers. Workers are going to kick in now and then say that, okay, I don't have anything to work for, I'm just going to be sleeping for a while. And MongoDB has started, you can see that sync workers are started now, and it says no food item to be synced, sleeping for 10 seconds. Store sync also kicked in, it is now working there. If I create a food item now, food item syncer will kick in and then get it up, and then we'll be working with that one. So it's basically running very nicely now. So just to prove that it's actually running. Yeah. So I can basically grab this URL here and then request one of the food items. Request one of the resources from the API. If it all works, great. So I'm just getting this from the actual place. It looks inside the MongoDB to get this, and then I'm being able to get it without doing anything else. So there's already a set of data that I have restored, and then it's working nicely. And even I can do some other shiny stuff like hit the search and do the search, and it will hit the Elasticsearch to do the search. And I can even ask some complex questions which would include looking at Neo4j, and it would go and look at the Neo4j. I can create new recipes, and that would kick the workers and then it would go up and do that. So inside the development environment, you have everything running as a cluster if you want to. Or you can say that, okay, I'm going to be only working with one piece. I don't care about the others, right? This is good if you want to do some integration, coherence test, or coherently run everything. But we haven't actually got the domain right yet. So we have like a big monolith application running because we want to get the boundaries right. And then after that, this is going to be probably split into separate repositories. And every team is going to be working on individual stuff. So at that point, you wouldn't need this type of architecture. You would only care about what you do. But at some point, you need to run everything in a coherent manner, right? So you would get a script up and running to do this, and it would get everything up and running. So which is, I think, very fancy, very cool. And you don't need to get anything installed rather than Docker and Docker Compose in this case, which is amazing. Deployments are amazingly easy because in terms of what your server cares, you are just pushing a Docker image there. Nothing else. It doesn't know about what's running inside it, and it just knows about which ports it needs to open up, which environment variables it needs to set, and you can even use some fancy clustering technologies like Marathon, Mesos. Okay.
How do I manage on which server, which property, which one?
That's all up to you. For example, if you the clustering technologies that I mentioned basically can do that for you, or you can basically say that, okay, I have these 10 servers, and I have this image, right? I'm going to be running it in each of them. So you would SSH into those machines, and you would run the command saying that pull this image from this registry and run that. And you would do that one by one. Or you can use a clustering technology, as I mentioned before, like Marathon, Kubernetes, or Docker Cloud, and that would run that command for you by SSHing into the machine. So in servers concerned, it's nothing that nothing is different there. You are just running a process inside the Docker engine. One more?
You used Docker to build and images of .NET services.
Yeah.
You have some .NET.
Yeah, exactly.
They are going to be deployed on Ubuntu Linux machines or Windows machines.
I think there is no native Windows support today.
They are planning to for Windows Server 2016. But I'm not
exactly.
Sure.
So
what did you use so far?
I think they are trying to support Windows as well, but I found it very restricted. So I have been using Linux. I find it very easy to get up and running. But I think that Windows support is coming there.
With Mono?
Sorry?
With Mono? Or with what?
It's more what?
With Mono?
With Mono? No. For CLR, you can run for CLR if you want to. For CLR just released RC2 a few days ago. You can run for CLR there if you want to, or you can run even Mono. It's all up to you.
Can you explain how you do the link between two instances?
Two instances.
Yeah, you open ports, and those ports are available only for one machine, from one Docker instance.
So, for example, in my case here, so I'm getting this image, and that image is opening up two ports for me, and these are these ports, and I'm saying that map these ports to the host with this, which I don't have to, but I just want to get the management up and running. But if you don't do this, if you just have this link, with this link you can connect to that container.
Any port.
In any port. So you can basically open up two port ADs, but the IP addresses will be different. So you are not going to be localhost AD. So you can't have two same ports inside the localhost, but you can have same port running on different IP addresses. So whenever you get a Docker container up and running, it will assign you a new IP address that you will basically use that IP address to connect to that Docker image. But when you link to it, it will basically put that link name of the container inside the host file with the IP address of that container, so that you wouldn't need to type the IP address. You would just type the container name. But there's also something called service discoverability that is being, done with some, but I don't find it, that mature to run it in a production environment. So if you do service discoverability, you will discover the services, dynamically, and then you wouldn't need this linking at that point. But just Google for that, and you will find some stuff. I think we have done now maybe one more. Fast.
I was just curious about how do you do monitoring and resource restriction on Docker? For example, preventing a user from starting up 50,000 containers and using all the machine's resources.
I don't think Docker is good for that. So whenever you need type of stuff, I think the virtual machines is better in that case. So I'm not that of an expert on that, but I know that Docker is nothing. It doesn't give you that much of a security boundary in that sense. It's just a process. I see it that way. So you can basically consume any type of memory as you wish to. Maybe there is some restrictions. I'm not aware of them.
Okay, thanks.
All right. Thank you very much for coming. Hope you enjoyed the talk.